And that's something that people don't understand
Yeah.
because the system may be functioning pretty well. They don't necessarily understand the limitations, nor do they understand that the system is assuming that the driver is engaged and ready to take over if there is a hazard. And so if they're disengaged from the driving task, even momentarily, and a hazard comes up, then they don't understand the limitations of the system or that the system is depending on the driver to be there and ready to make that decision that it truly is a hazard.
Hi, my name is Junko Yoshida. I'm the editor-in-chief of Phil and Junko on AV safety. And with me today, we have my partner in crime, Phil Coltman, safety expert and professor emeritus at Carnegie Mellon University. Hi, Phil.
Hi, Junko. Good to see you. And we have a great guest this week.
I know she was highly recommended by Phil, and I agreed. She is Kristin Poland at National Transportation Safety Board. Hi, Kristin.
Oh, thank you so much for having me today. Hi, Junko. Hi, Phil.
Uh,
Hi,
Nice to
Kristen.
have you. I mean, this is such a treat because I'm a reporter. I read the NTSB's reports, right? Investigation reports. And usually quite, they're very factual, quite dry, and I don't really see the people behind the report, who wrote the report, who actually investigated the crashes, right? So it's really honored to have you, Kristen. Thank you.
Yeah, thank you so
And
much.
let,
Thank you for reading our reports. We appreciate it when people read the reports and so much enjoy talking about the work that we do because there's a lot behind the scenes as
Yeah,
well.
yeah. All
and let
right.
me add that the NTSB is the gold standard for accident mishap investigations. And what not everyone knows is of course, they do airplane crashes. That's in the news all the time, but they do some car crashes, not all, but some. And this is a great opportunity to learn from the folks who really look that closely at the crashes.
Very good. All right, Kristen, let's start with you. I mean, could you give us a brief introduction now who you are and what do you do at NTSB first?
Oh, yeah, I'd love to. So, as you said, I currently am the Deputy Director of the Office of Highway Safety at the National Transportation Safety Board, or the NTSB. I have been at the NTSB for almost 30 years now. I
Wow.
came to the NTSB in our Office of Research and Engineering. My background is actually engineering, so I come at a lot of our problems from an engineering basis. I have an undergraduate degree in mechanical engineering and a PhD in biomechanical engineering. So when I first came to the safety board, I focused on how people were injured and killed in crashes of all modes. So that included aviation crashes, highway crashes, rail crashes. And I looked at what types of solutions we had across the modes and how we could apply those. And of course, over the years, I learned, especially in the highway mode, that there are just some circumstances that are very extreme and hard to protect the occupants in. And I started looking into crash avoidance type technologies, which of course then led to these types of systems we're going to talk about today. Partial automation systems and how those systems can help us bring the types of crashes that we're seeing either by preventing them or in some cases reducing the severity of those crashes such that the forces are now tolerable by the occupants so that they can escape without injury, for example. So I moved into our Office of Highway Safety almost 10 years ago now and have had the opportunity to work in many different crash types. So that can be commercial vehicle crashes or passenger vehicle crashes. I participated on the first fatal partial automation crash that was in Williston, Florida in 2016 and helped bring that report forward and all the subsequent ones since then. Our office is also responsible for infrastructure failures. So if you're familiar with some bridge crashes, some people remember the Minnesota bridge collapse, or more recently when the container ship Dolly hit the Key Bridge in Baltimore. Our Office of Highway Safety was responsible for the bridge aspects of that, and our NTSB's Office of Marine Safety was responsible for the aspects associated with the dolly. So it's a wide variety of work that we do at the NTSB.
That's great.
I'm walking distance to the front hollow bridge, so I know all about the bridge collapse issues. That was one of the more recent big bridge investigations.
Yeah, yeah, Pittsburgh, of course. Yeah, that was a cold day and a very lucky circumstance because there was a bus on that
There was
bridge
a
when it
bus on it.
collapsed.
That's right. Everyone got out alive, and that was really remarkable. Yeah.
Interesting. All right. So before going further, I mean, Phil and you both actually briefly explained what NTSB does. But can you explain really what the differences are between NTSB and NHTSA?
Yeah, that's a really good point to bring out because NHTSA is the regulator. So they focus on highway safety, but they focus on vehicle design. So they set all of the federal motor vehicle safety standards that define the minimum standards for how our vehicles are designed. They also can do crash investigations. And of course, they maintain the databases that have pretty much all the fatal crashes that we have in the United States and also serious injury crashes. And they have a defects investigation group that can also look at circumstances where there may be a defect associated with a vehicle. The NTSB is different. So when we were originally formed, we were part of the Department of Transportation. But quickly, there was a realization that the NTSB needed to be an independent agency because we were making recommendations to a Department of Transportation, which of course wouldn't make sense if we were underneath the Department of Transportation. So in the 1970s, we were made an independent agency, and we are only an investigative agency. So we investigate every civil aviation crash in the United States. That's where a lot of people know us, is from the aviation crashes. But we also have responsibilities in all modes, including crashes in highway safety. Most importantly is that we're not a regulatory agency. So we cannot force people to do the safety improvements that we identify through our crashes. We issue safety recommendations to recipients that we think can make the safety improvements, and then we try to influence them to make that safety change. Another unique aspect of the NTSB is that we work our investigations through what's called a party process. So this is a very collaborative process where the people that may be involved in the crash somehow. So for example, a vehicle manufacturer, we're going to talk about it soon, but in the report that we just put out, Ford was the manufacturer of the main vehicle that we'll talk about in the two crashes that we just completed a report on. Ford was a party to our investigations, which meant that they participated when we were on scene, gathering our initial data and factual information about that crash. They also participated as we were doing the post-on-scene work and helped us to understand how their system functioned. If we had questions, if we wanted additional data or additional understanding of how data worked, Ford participated with us as a party to that investigation. Importantly with that is that they also have awareness of all of the factual information that we're gathering, which helps them to recognize when safety improvements are needed. So when I talk about the NTSB not being a regulatory agency, we have that party process, which often allows the recipients of our recommendations to be seeing where safety improvements can be made throughout the investigative process. And then when they are issued a safety recommendation at the end, they already know that it's coming to them, and oftentimes may even have a plan if they have recognized that that safety improvement was needed.
Wow, that I didn't know. That's very interesting. All right, so Kristin briefly mentioned today's topic is the two BlueCruise crashes, of which the NTSB recently investigated. And before going into this discussion further, I would like to get Phil's help to quickly provide background of those two BlueCruise crashes. Phil?
Sure, sure. Let me dive in for a minute. And Kristin, I'm sure you will have more to say. Well, I'll give you a chance for that. First, on the NHTSA versus NTSB, I've seen that confusion so often because sometimes NTSB and NHTSA, National Highway Traffic Safety Administration, will both be investigating the same crash at the same time. And sure, you can collaborate, but why would that happen? Well, NTSB, they're there to tell everyone how to avoid the next crash, how to make it safer, which is great. But it's collaborative. It's a let's learn the lessons, right? That's what it's about. NHTSA is there for a somewhat different reason. Not that they don't want lessons to be learned, but that's not really their role. Their role is to decide whether to do a recall. They're there to pull out the regulatory recall hammer and say, guys, you have to change this. And those two things are compatible, but they're not the same mission. Now, there are two crashes, and these are both Ford BlueCruise, which is a SAE Level 2 driving automation system, which means the driver is required to continuously monitor and jump in if something goes wrong. It's not a robotaxi system. It is a driver is watching the car drive. And really importantly here, it's okay for the driver to have their hands off, but they're supposed to be watching. The first crash was in San Antonio, Texas. And so this is in February 24th, 2024. It was at just before 10 p.m. local time. So it's dark. It's evening, but not super late. It's a 2022 Ford Mustang Mach-E. It's at 74.7 miles per hour in a 70 mile an hour zone. So a little over the speed limit, but not crazy. And it runs into the back of a Honda vehicle. It's fatal to the Honda driver. The Ford driver has a minor injury. And what happened was the Ford driver was operating in hands-free with BlueCruise on and did not apply braking, and the system didn't brake, didn't steer, system didn't steer. So it just ran right into the back of this vehicle. Findings were that the Ford driver was distracted, probably from in-vehicle navigation looking for a charger, for example, and had over-reliance on hands-free partial automation and disengagement from the driving cast. Pretty quickly before this crash, another human-driven vehicle had gone around the Honda. So you can't really say it was impossible to avoid the crash because somebody just did that a moment before.
Yeah, so you hit the nail on the head with the description. Just wanted to point out that while it was nighttime, the roadway was lit. So there was adequate roadway lighting. You're right, the Honda was stopped in the center lane. So it was stationary throughout the entire approach. We do believe that it had lights on. So we did some work.
So it did have lights on. Okay.
We're not
but it was
exactly
stopped.
sure. It was stopped. It was stationary.
Yeah.
We also did some work because you're right. There was a human-driven vehicle that was in that center lane that had avoided the crash with the stationary vehicle. And then the driver of that vehicle was actually a witness to the Ford hitting the back of the stationary vehicle. But we did a lot of work to try and determine whether it was a cutout scenario. And in this case, we don't believe it was a cutout scenario. We believe there was enough separation between them so that wasn't the case.
Excuse me, I'm just a layman here. What do you mean by cutout scenario? Can you explain?
You're following a car. The car swerves and you go, oh, look, there's a boulder in the road. And you have no time to react. That's a cutout.
So it's like you can't see it because the car in front of you is blocking whatever the hazard is, and they suddenly avoid it, and then the hazard is revealed to you late in the game, and you don't have enough time to respond. But we spent a lot of time pulling that out.
If they swerve 10 feet before the boulder, you have no time, right? Because the stopping distance assumed they had 1G braking, not instantaneously braking, right? So that's basically a no-win scenario. But it doesn't sound like it was a no-win scenario in this case. It sounds like
we think there was enough time. So based on what we were seeing, the Mach-E was maintaining a set cruise speed, and it was pretty much a constant set cruise speed. We knew that human-driven vehicle wasn't using any sort of cruise control. It didn't have an adaptive cruise control system, but the driver reported that she wasn't using cruise control, so we would have seen more variability in the speed differential. Whereas in the Ford's case, we just saw that constant speed right into the back of the stationary vehicle, or essentially the constant speed.
And even if it was physically impossible to stop, you would have expected to see brakes come on, and you didn't even see that. So it didn't even try. Yeah.
Yeah, no steering, no braking, just straight in, which of course then gets into, the driver monitoring system and what information we got from the driver monitoring system. But I'm sure we're going to get into that a little later.
Yeah, that's right. Now, does the BlueCruise have LiDAR, or is this camera only?
So they have radar and camera based
but
systems.
no lidar, right?
Right.
And radar has trouble with stopped objects because of ground clutter return, and camera has trouble with stopped objects because distance estimation is not so easy, even because you have a very small stereo baseline, even if you have stereo cameras.
Right. And then we're also dealing with the confidence of those systems and,
Yeah.
backing up to that level 2 system, which is designed to have the driver be engaged in the driving task, then they really don't want to apply braking or take some sort of serious evasive action when they know the driver is also there as a backup. So they need higher confidence. So even if you had a
That's right.
radar system that may have seen something, if it was a really low confidence, you wouldn't have it engage emergency braking, for example, because the driver's there to back up the system if it truly is a hazard.
Well, this is an important point that's underappreciated. People say we have a level 2 system. We're going to magically flip a switch to be level 4. And one of the things that's completely different is when you have an assistant behind the driver, if you're not sure, you don't act because phantom braking, you get hit from behind. That's the computer's fault. But if you don't brake for an object, you can say, well, the driver should have seen it, not our problem, right? So they're going to tune it to avoid false alarms. Once you get it to a level 4 robotaxi or similar technology, now there's no human driver to blame. So you're going to jam on the brakes much more often and get hit from behind and people complain about that. But you can't afford to take a chance. If it's black and white, fine. But if it's gray in the driver assistance, they're going to just let it go because they don't want to do a false alarm. But when it's a robotaxi, you have to actuate because you can't take the chance on being wrong. So you can expect that this driver assistance technology, if it's not sure, it won't do anything and it'll be on the driver. And that is the way you design these forces you, incentivizes you to end up at that place. Right. So that means the driver has to be paying attention because if it's not sure, it's on you, man. It's not, the computer's not going to save you.
And that's something that people don't understand
Yeah.
because the system may be functioning pretty well. They don't necessarily understand the limitations, nor do they understand that the system is assuming that the driver is engaged and ready to take over if there is a hazard.
Well,
And so if they're disengaged from the driving task, even momentarily, and a hazard comes up, then they don't understand the limitations of the system or that the system is depending on the driver to be there and ready to make that decision that it truly is a hazard.
and it's
Yeah,
tricky because it feels like it has it, but it actually is aggressively not having it. It's on you, right? So that's tough to get your mind in the right place if you don't understand that design trade-off.
Yeah, and we'll get into this because you're going to talk
Yeah.
about the Philadelphia crash. There was a
That's
second
coming
one.
up right next. Yep.
Yeah, but
Yep.
that's where these two crashes highlighted where those limitations are. So I know you're going to get there.
Yep.
All right, so let's move on to the
Okay.
Philadelphia crashes.
So the second crash was in Philadelphia. This is March 3rd, 2024, and it was at 3:16 a.m. local time, which brings to mind the bars have all closed down and stuff. And yeah, that turns out to be relevant here in a way. It's also a 2022 Ford Mustang Mach-E. It's traveling 72.4 miles an hour on a road that would normally be high speed, but there's a work zone. And the work zone speed limit is 45 miles an hour. So this is almost 30 miles an hour above the speed limit, but footnote, it's a work zone, so it's not the normal speed limit. Now it's 3 a.m., so I'm guessing there's no workers actually in the area, but when you're in a construction area, things are a little more dicey always, even if nothing's going on. It was a complex crash. I'm not going to try and go into the crash physics because it's beyond what we're here for, but the Mach-E crashed into a stationary vehicle, and then two other vehicles got involved. So it was a real mess. There were two drivers died that were in the other vehicles, and there was a minor injury to a Ford driver. And the Ford driver was impaired by alcohol, clearly above the legal threshold for impairment. And it was possibly worsened by cannabis use, although that's tricky to judge. And probably was distracted by cell phone use. And again, the finding was over-reliance on and misuse of the vehicle's hands-free partial automation system. I've observed that people will buy this technology with the explicit intent of having it drive them home after they're drinking. Now, I know you have limited data, but as far as you can comment on that, and I know we're speculating because NTSB has not done the analysis across the population, but for me, this is completely foreseeable, almost incentivized misuse and abuse. And I think we have to sort of think about that. So go ahead. I know there's a lot to talk about from your side on this one.
Oh my goodness. Yeah. So good summary of the Philadelphia crash. Like you said, when you're talking 3 a.m., we are looking at potential impairment, and that was the case, alcohol impairment for this driver. Um, the level 2 system, we were talking about it before. It is dependent on the driver to be engaged in the driving task and to be able to identify hazards. In this case, similar to San Antonio, we had 2 stationary vehicles. In this case, they were in the left lane. The Ford vehicle was also in the left lane. So the Mach-E was in the left lane. One of the people in the stationary vehicle had gotten out of their vehicle and so was talking to the other. We don't know exactly why they were stopped there, but obviously we can make some guesses that there was something wrong with at least one of the vehicles there. So recognizing that hazard, again, we have the nighttime driving, we have some lighting in the area, and we have the work zone. But importantly, if a person is impaired and they're driving a level 2 vehicle, they are still responsible for driving that vehicle. And so impairment, any type of impairment, alcohol impairment obviously is bad, but any type of impairment, whether that's fatigue, whether that's distraction, whatever that is coming from, alcohol or other drugs, we know that the vehicle is dependent on the driver to be engaged in the driving task. And if they're not available to take over, then we have this type of a scenario where we have fatalities resulting. Now, the NTSB has addressed alcohol impaired technologies. And in fact, we reiterated a recommendation, a safety recommendation in this report focused on in-vehicle based technologies that can detect alcohol impairment and can either prevent the vehicle. For example, if this driver had gotten in and was impaired, most likely based on the level that she was detected at, she was impaired at the start of the drive, then the vehicle wouldn't have been able to go forward, which of course is, what we want. We don't want the drivers to be driving the vehicle impaired. We certainly don't want the driver to be engaging some sort of partial automation system that they're monitoring and be impaired. But we also can say that some of those systems may also limit the ability of the vehicle to move forward as well. So yeah, as Phil, as you pointed out, the NTSB has a long history of trying to prevent alcohol impaired driving. And we know statistically, it's about a third of our fatalities on the road today. And that means almost 13,000 people die every year as a result of alcohol related crashes.
Wow.
It's important to point out, it doesn't have to be that way. People say, well, there's nothing you can do. It's just not possible to get better without robotaxis. And I look back in 1985, and at that point, the UK had a slightly worse fatality rate than the US, and their drink driving rate was lower in 1985 than ours is today, because they just finished a campaign to address that. So we could do much better. They're down at like 12 or 14%. They're half of ours. And so we could, in principle, you can't say, well, it's impossible because other countries have done it. The US chooses not to. And I know that must frustrate the NTSB no end because this has been a long-term problem. Let me hit another couple points. One is that we see companies actually saying, oh, yeah, our car is safer than a human driver. And, therefore it can drive you home safely. But what they don't say is their data is for an alert human driver plus their automation. And if you take away the alert human driver, the finding that it is safer, which is, by the way, controversial and probably not really true. But even if it were true, if you take away the responsible alert human driver, it's probably not safer. And it just irks me that they make this argument, which is just ridiculous, right?
Yeah, so we talked about this in the board meeting where what type of marketing is going out from the different vehicle manufacturers associated with these types of systems. So we've been talking about it as SAE level 2 or partial automation, but we can also refer to it as an advanced driver assistance system. It helps the driver. But if the marketing is telling the driver it's doing more than that, it's more than helping you, it's doing it for you, for example, or it's okay if you're driving and using a hands-free system, but you're distracted. Maybe you're not looking at the forward roadway or you're paying attention to other things, then the messaging is poor. It's not telling the user that there are limitations of this system and you need to be engaged. And as Phil pointed out earlier, these systems function really well. It makes the driver think that the system, the car, has it. It's doing a great job. I can depend on this. And that's where we get into the over-reliance because it functions so well most of the time. And, we all drive, so we know that most of the time our drives are normal. We don't encounter a lot of hazards most of the time, but every now and then something really scary happens and you're like, thank God I was paying attention and, anticipated or saw something happening and I braked and steered away from it and I avoided a crash. So that's where the marketing to be conveying the same type of information as we know as researchers, as engineers, that there are these limitations and that these systems aren't perfect. And we're going to get into that. That's what we were seeing in these two crashes is that at these types of speeds in a nighttime environment with stationary vehicles, the systems are totally challenged. They cannot detect and prevent this type of crash. And in some cases, like in San Antonio, doesn't even react to it whatsoever. In Philadelphia, we know that there was a call to a warning system, but at the very end, less than a second, we don't even know if the warning was provided to the driver because it was so late in the game. And in that case, it was only a warning. It wasn't even an automatic emergency braking or something else to help mitigate the crash scenario. So again, we need to give this messaging to people that when you're driving these types of systems, it may be helping you. It may be helping you steer. It may be helping you with your speed control. In no way is it driving for you. You are the driver. You need to be engaged in the driving task. You can't be distracted, can't be fatigued. Obviously, you cannot be impaired.
And that's tough because if you're driving 999 miles and it's been amazingly competent, you're just not ready when that 1,000th mile it tries to kill you. I mean, you're just not. And that's not, by the way, these comments at this point are not limited just to the BlueCruise product. We've seen this across all the brands that the better the automation is, the harder it is to remain vigilant and to intervene because it just lulls you into automation complacency. And I agree that the advertising is a problem. There was even a commercial that was shown during the board meeting. I thought that was pretty interesting. But they're not the only company who's shown those kind of commercials. There's famously been commercials from other companies that dramatically overstate the capabilities of the system. And you can't say, well, look at us in a TV commercial. Look at us. We drive for you. And then in the fine print say, yeah, but it's entirely your fault. You're not going to get outcomes if you do that.
And that was something that we brought out in some of our earlier crash investigations where we were seeing, and you mentioned this at the beginning, if a vehicle isn't able to operate, if its operational design domain doesn't include surface roads, for example, maybe roads where you have cross traffic on it, we shouldn't be dependent on the drivers to understand those limitations and self-limit. The vehicle should self-limit based on the environment that it's in. And that is something that we saw in the BlueCruise crashes that it did. It self-limited to roads that were pre-mapped, to roads that met the specifications where the BlueCruise system could function. So really good in that sense, better than what we had seen before, but still showed us some of the limitations.
Well, from a learning point of view, the previous NTSB findings had been you really need to enforce your operational design domain because people just are never going to be perfect at that. That's a whole nother rant I can do about, so it's 50-meter fog. What if it's 49 meters? And how would a person know, right? There's some things which people are just never going to be able to be good at, and the technology should do that. But things like, well, no, this road, a regular definition map knows there's cross traffic. There's no reason to enable it on that. And so that was one of your recommendations. And Ford seems to have addressed that because they only run on mapped roads. Super Cruise from GM, the same thing. So this is a good thing. And the other one was camera-based driver monitoring is going to be better. absolutely it's better. But it turns out both of those things aren't quite good enough. So what do we have left? What are the things? I mean, they made progress. Everyone's on cameras or getting there. The old cars don't necessarily have cameras, but all the new cars have cameras for driver monitoring if they're the L level 2 plus plus, whatever that means, right? The high-end ones. They have cameras. And they're either declaring there are no limits or they're limiting themselves to roads, depending on the company. But there's clearly stuff left. So what are the findings from this one? What are the recommendations about how much further we have to go on this?
Okay, well, we addressed a couple of aspects, and let me just start with even being aware of the crashes. So we know that NHTSA has a standing general order, or SGO, that requires vehicle manufacturers, whether they're in the partial automation side, like we're talking about today, or if they're in more of the highly automated side, maybe SAE level 3, 4, 5. If they have an incident, a crash, or maybe certain circumstances near crash, they need to report information to NHTSA about that crash. But you have to know about a crash to be able to report that. And of course, that gets into you have to know about a crash then to be able to do the work that the NTSB did for these two crashes to be able to gain the insight that we'll talk about in a minute. So San Antonio was an interesting crash. The Ford driver survived that crash. And a bit after the crash, he posted to a Mach-E user group, online user group about the crash that he was involved in and had some questions. So that flagged Ford that there had been a crash so they could reach out and learn more information. And of course, then they reported that to the SGO.
But they have a telematics system. Didn't they know? Did one hand of Ford know they had a crash, but the other hand didn't know? Is that what was going on there?
Okay, well, really good point. So during the investigation, we learned that there is recorded information in certain spots on the vehicle, but Ford also has a telematics program. Now,
For the viewers, telematics means it sends data home. Just
exactly.
a simple version.
So
Okay.
the sensors on the vehicle send a certain amount back to Ford. So, for example, in our investigations of the Tesla crashes, like the Williston, Florida crash that we talked about, that telematics data recognized that there was an airbag deployment and sent information to Tesla so that they were aware that there was a crash that happened, and then they could take action to see if the driver had survived or if there was any assistance needed for the driver.
And since not everyone has memorized the crashes, that was one of the Tesla hits a tractor trailer crash.
Yeah, that was the first fatal crash.
It was the first fatal crash for Tesla. Okay.
Yep. In the Ford case, they do have a telematics program, but they don't use it in the same way. They don't use it to identify when crashes happen. They're using it for other purposes.
But they have it. They get the data. They're just not looking at it, is what it amounts to. Not for that.
They don't have it triggered based on what we would consider crash type data. So they don't have telematics triggered for an airbag deployment, for example.
They could. There's no technical limit, right?
Yeah, they could have it triggered for automatic emergency braking or for stability control systems or for any other type of pre-crash scenario. They could trigger telematics and start looking at the scenarios.
So it was their choice not to do that. Is that it?
Well, yeah, so it's their choice, but I also want to point out that the NTSB recognized that this was a choice back on that first fatal crash in 2016. So that report that came out in 2017 said that NHTSA should require an enhanced electronic data recorder that would then record information associated with partial automation as well as crash information so that we would have awareness of when these crashes were happening. So we recognized it, almost, I guess, at the time of these crashes, it was about, 7, 8 years earlier than that, and had been asking NHTSA to do that work.
So what's happening with NHTSA is they have a thing called SGO, Standing General Order. That's just the name that's stuck to it, but it's a data recording requirement. And the thing about the data reporting requirement is if the car companies know, they have to report, but there's no obligation to go looking. So there is a structural incentive to avoid triggering on crashes, because if you don't know, you don't have to tell anybody. So they're getting the data back home. The data is in their server. And if they put in a business logic rule that said, oh, if airbag flag deploy, tell someone to pay attention, and that trigger's not there, plausible deniability, right? not even I don't even think it's plausible. I mean, they have the data. It's willful ignorance is what it is. I'm not a lawyer. I'm just talking, but that's what it
Yeah,
feels like to me.
they were looking, but not in the sense of what we would want them to look for. So
Yeah, they weren't looking for crashes so that they could report them. They were looking for engineering data, and they had omitted the triggers that would have told them, hey, there's a crash.
And that's what we think there should be a certain amount of information recorded on these vehicles to allow this awareness. And like I said, that one Ford became aware of shortly after the crash. The Philadelphia crash was a totally different circumstance. So in that case, NTSB learned about that crash about a month after it happened because our investigators had investigated a previous crash. You probably remember this one. It was a tractor trailer that took an off-ramp too fast. It rolled over. It was a fuel tanker. And unfortunately, a huge fire happened and it brought down an overpass on I-95 near Philadelphia. So I-95 in that area.
Oh, that was a mess. That was a mess.
Exactly. Yeah.
That was the one where they got the new overpass in record time. I recall that one.
Exactly. Yeah. So those same investigators were investigating this BlueCruise crash, and they reached out to our investigators about a month after the crash and said, hey, we think the driver was using BlueCruise. We know she was impaired by alcohol. We're trying to get data associated with the BlueCruise. Do you have any experience with this, NTSB? And we had just dived into the San Antonio crash, and we were like, please tell us more. So, of course, we picked up that investigation in Philadelphia. We asked Ford if they were aware of the crash, and they weren't at that point. And so then once they looked at it, then they did the required reporting to the SGO. But that's a circumstance where that crash could have easily been missed by our investigation team, by other investigators, and all of
How would you know? How would you know, right?
Exactly. Of what limitations. So all that to say, when you ask, what are our recommendations? Well, first and foremost, we want the data recorded so that we have awareness of when crashes or even near crash events are happening so that the manufacturers can look into it and understand, how are these systems functioning? Are there limitations? Can we improve these systems? And then that would also be accessible to NTSB investigators and NHTSA investigators and obviously others to try and improve these systems. So now we can get into, well, then we have additional recommendations because of the limitations we saw in these crashes. We recognize there's improvements for driver monitoring systems, for how the level 2 systems are engaged in the first place. They need to have automatic emergency braking included when they're turning on a partial automation system. We found in these cases that the driver could turn off automatic emergency braking, but then still engage a hands-free partial automation system, a hands-free BlueCruise system. But we know from the research that that automatic emergency braking system is really where our safety benefit is coming in. That's where we're seeing that huge benefit. But if the design of the system allows you to turn off the main safety component of the system and still operate the system, then that's a real safety problem that we saw, a real safety issue. So that, as well as Phil, you pointed out that it was almost 30 miles per hour over the posted speed limit in Philadelphia. We think that there needs to be that speed component. If you have a partial automation system, a hands-free partial automation system, you need to have intelligent speed assist be part of that system as well, because we don't want drivers moving into a work zone, even if it meets the requirements of a BlueCruise, but be able to operate the system almost 30 miles per hour over the posted speed limit. That's just crazy.
Let me pause there for a couple of the things, because I know I want to get to the impairment thing too, but trying to make sure we hit this. One of the issues is that AEB is only good up to a certain speed. And if you're counting on that, you shouldn't be driving faster than that. The other one is that it actually got turned off. It's like, and I know people do this, and they shouldn't, but it's like having airbags and taking off your seatbelt. It's like, no, you really need the seatbelt too. You have this level 2 system. AEB, as you said, all the data shows level 2 systems are convenience features. They're not safety features. the safety's coming from AEB, and this system let them turn off AEB. That's just nuts. If you're going to trust the automation to drive your car, all the automated safety features should be on at the same time. That's just common sense to me.
And of course, we're always talking about layering the systems together. So you mentioned that AEB only functions up to a certain speed, and actually the requirements don't go into effect until 2029 because
That's
NHTSA
right.
just passed the
Wow.
final rule. So even when we're talking about kind of these higher speed requirements, certainly these vehicles weren't required to have an automatic emergency braking system that would function up to the highway speeds that we're talking about here. Even in 2029, we're going to be above the speeds that would require total avoidance of a crash like this to a
And
stationary
that's
vehicle.
tough because you have automation complacency, and the thing that mitigates that is AEB, but it's not there for you.
Right. So this is where we get into kind of that stacking of the systems together that I was mentioning earlier. So we need to have the speeds be in a range where our automatic emergency braking can function. And then our automatic emergency braking can reduce the vehicle speed even further to give the driver time to either evade a crash, because if we have more time to a collision, maybe there's opportunity for me to steer around a hazard. It also brings it down into a more survivable range for the occupants. So if I do have a crash, then I'm in a speed where my seatbelt, my airbag, my pretensioners, and load limiters can all function together to try and reduce harm to the human that's involved there. And so again, I think a lot of times people will look at these as just one system. Well, what difference would it make if automatic emergency braking was on because it was still too high a speed? We want these all to be working together by design from the get-go. And that's where we feel like, and this is one of our recommendations, we said that we thought the Department of Transportation should provide guidance to the manufacturers on how these systems should be incorporated into SAE Level 2 system. We recognize there's been a lot of guidance from the Department of Transportation for higher levels of automation, but they kind of skipped over the level 2 systems.
Yeah.
So then it's up to the manufacturers of how they're going to implement it. And that's where we start to see some of the challenges.
Yeah, and everyone who's not a robotaxi is going to be level 2 plus, 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 plus. We know that's coming. Go ahead, Jenka.
All right. I have one question. They're talking about AEB. I read kind of contradictory reports that the one of the crashes wasn't caused by the driver turning off AEB. Was that the case, or that the real issue here is that AEB is not designed to be working in conjunction with DMS? I mean, how should I think about this? Yeah.
You're right. So it wasn't the case in these two crashes that the driver turned off AEB, and that's why the crash happened. That was something that we saw on the side. That was something that could have happened, and that would be a disadvantage of these systems. So AEB could have been disengaged. But ultimately, like you said, in both of these scenarios, the vehicle was not able to detect the stationary vehicle with enough confidence to take any sort of evasive action. So the vehicle itself did not apply any sort of braking or any sort of steering. And similarly, we're talking about disengagement from the driving task for both drivers and over-reliance on the partial automation system. So in both cases, neither driver took any sort of evasive action. There wasn't a last-minute slamming on the brakes or a last-minute steering to try and take some sort of evasive action. So the AEB aspect is something that we saw as an additional hazard, but wasn't contributing in this case.
Okay.
So here's something that bothers me about this, that you have the system that isn't sure whether it should brake or not, so it doesn't. But it doesn't bother to tell the driver, hey, I'm not sure. You should be paying attention because I don't know what I'm doing here. Yeah, that's what we're saying. Now, I can speculate that's because the manufacturers worry that if it keeps saying it's not sure, people will say it's not good. But from a safety point of view, every time it's not sure, it should be telling you, hey, I don't know what I'm doing. Pay attention. But that's not what we see, is it?
Yeah, that's a really hard human factors aspect. ultimately, these are designed to be advanced driver assistance systems. It's an assist to the driver. It's reducing some of the workload for the driver, but the driver is responsible. And so, you could envision where if it was saying all the time, I don't know, I don't know, I don't know, you could also have a driver disengage from that type of a warning system.
That's right.
We think by design, these systems should be designed to incorporate the aspects that we've seen in the Tesla crashes as well as in these two Ford crashes, that drivers can disengage from the driver. As we talked about, this is a better environment than we were in 10 years ago. We have a system that's limited to its operational design domain, and it has a camera that's facing the driver. But we saw limitations. We saw that the camera system, while functioning really well to look at where the driver is looking. Is the driver looking at the forward roadway or at the infotainment system, for example, in the San Antonio crash? Unfortunately, while the system knew the driver was looking at the infotainment system, just short glances back to the forward roadway, less than a second, and back to the infotainment system were enough to reset the driver monitoring system to say, oh, the driver's engaged. We know when we're driving, if I am looking at the infotainment system, the driver reported he was looking at the infotainment system for navigation to find an EV charging location. If he looks up momentarily and then back, it's not long enough to re-engage in the driving task or to recognize a hazard like we have with a stationary vehicle in the center lane. So totally unexpected.
But it's enough to fool the driver monitor. And what I've observed is that people learn to modify their behavior to keep the driver monitor happy, even if it's not actually effective. So it's possible that driver taught themselves to do the glancing to shut up the driver monitor, and that's a learned behavior. That's possible. I don't know in this case, but I've seen other instances where that's basically the outcome you get.
So along those lines, though, the system can recognize that 0.4, 0.2 seconds of looking at the forward roadway isn't enough to re-engage in the driving task.
Should, but didn't in this case,
but
right?
Didn't. And of course, that's part of our recommendations as well.
Of course.
Now, we've talked about how the Philadelphia driver was impaired by alcohol, maybe worsened by cannabis. But we also know, because there was a single image that was recorded for that vehicle, that the driver was holding an object, most likely a cell phone, looks like a cell phone, seems like a cell phone. But importantly, the location of where the camera is that's looking at the driver monitoring camera, is on the steering wheel column. So it kind of looks along the steering wheel column up towards the driver, and then the steering wheel is around the outside. So it's looking to see where the driver's looking. According to the camera, the driver was looking at the forward roadway. Unfortunately, the driver was then holding the cell phone on the top of the steering wheel, which would block their line of sight to the forward roadway.
Now, the chance that's accidental, that's not accidental. I'm going to say, you don't have to say it, but I'm going to speculate that this driver had learned they could fool the driver monitoring system by putting their phone in front of their gaze to the roadway.
Well, you mentioned it earlier. We said it in our probable cause. That gets into the misuse. This is a misuse of the system. Using the system when you're impaired, that is not how the system is supposed to be used. Using a cell phone, obviously we're not supposed to be driving while we're using a cell phone in any circumstance.
Yeah.
But importantly, just because the vehicle may be doing a part of the driving to assist the driver doesn't mean you can then go do another task. You're still supposed to be involved in the driving task. And so, we had a driver that was impaired, most likely using a cell phone. We think the driver monitoring systems can be designed in a way to detect. And we're seeing that in other countries. So Euro NCAP has a look at, can the driver's eyes be obstructed by something? So in the case of putting the camera on the steering wheel column, very hard to detect if there's something in the forward roadway. But you could envision a camera in a different location looking at the driver that would also give an idea if something was blocking the driver's view of the forward roadway. And then obviously, if the view of the forward roadway is blocked, how can they be engaged in the driving task?
And I think this is an important part of the process. No one expects, or no one should expect, this technology to be perfect out of the gate. There's always things you didn't think of. What's important, though, and the critical role of NTSB is to say, here's some learnings. People are going to put their cell phone on top of their steering wheel so it looks like they're looking at the road. People are going to drive impaired, and there's various reasons that may motivate them to do that. Now that you can't pretend you don't know this. You have to do better. And so what I hope we see is the industry respond to these learnings to further improve their systems. That's what matters. That's the takeaway from all of NTSB work is that the relevant transportation mode is supposed to learn the lesson and get better.
Well, that's where we appreciate being able to come on your podcast today to share that type of messaging, because not everybody recognizes the work that the NTSB has done and takes that learning. So the more we can spread that type of learning through these types of discussions, reaching a wider audience, then when people are thinking about the engineering solutions, they're thinking about the mishaps as well. How are humans going to be using this type of system? Not the ideal case of how they're going to be using it, but the real world case.
Yeah,
People
blaming the driver isn't going to stop the next crash. It doesn't work that way.
No, yeah, no. And of course, that circles back to we need to know about these events when they happen. So we want there to be recordings of these. We want there to be telemetrized information that a crash has happened when an L2 system was engaged or around the time of an L2 system being engaged, so that we can have these learnings to improve these systems and hopefully get us to the point where obviously we're on that road to zero, but we're a little bit under 40,000 fatalities every year. We see promise with these systems, and we talked about that with these advanced driver assistance systems when we're talking about automatic emergency braking, lane departure prevention systems, stability control systems. All these help the driver out. But we need to learn what the challenges are and maybe even how people are using them or using them inappropriately, so that we can then take that engineering approach of how can we design them better in the future. So, we hear a lot from the NHTSA Standing General Order. We hear a lot of certain types of crashes, fewer from many other manufacturers. And that was something that we brought out in this report, that we believe that there are likely more crashes that are happening that aren't recorded because they're not required to be recorded. They're not required to telemetrized system. And so, we don't know for sure because the data is not out there. But from our experience and from our communications, a lot of times that crash-related data is stored only on the vehicle. And so if you don't go out and try to download the information from the vehicle, and of course, this is not just downloading the ADR. We had to download data from a lot of the different components. So it's more work. And that's where, like, the police don't necessarily get the data just from downloading the electronic data recorder. There's more to it.
Yeah.
Yeah, this is not going to fix itself because the car companies have an incentive to not be aware of the crashes. So this is where you typically need regulations to overcome that, the incentive to do the wrong thing.
Right. So electronic data recorders, as you know, they're not required to be on vehicles, but if they are on vehicles, they need to record a certain amount of information. There was just an update to the EDR requirement to include additional time before the crash, so 20 seconds instead of 5 seconds. But we still think there's opportunities to improve that more so that there can be recorded information associated with level 2 operation, which is not currently on there or certainly not required. We see some manufacturers may have some components of that, but the type of information that we needed, and honestly, we were very fortunate that Ford did have recorded information. They did have some telemetrized data that we could look at to understand what was happening in these crashes. We were able to, in some cases, get data off the BlueCruise module. But in one of the cases in San Antonio, we were missing data, and we never could exactly say why that was the case. So, that's another limitation is if you're not required to record the information, it may not be in a centralized location. It may not all be available, and it takes a lot of time and effort to pull that information together. I mentioned Ford was a party to our investigations. That was very fortunate because they could help us pull the data from various sources together and associate the timing back to the crash so we could understand if we did have alerts or did have warnings associated with the driver monitoring system, how far were those from the crash time period? But again, it takes a lot of time and effort, which if there are more crashes, we need to have that information telemetrized to the manufacturer so that they have awareness and others have awareness, but also recorded in a manner so that we can get the information about how these systems are working so that we can make continuous improvements.
All right. I would like to wrap up this podcast by asking two additional questions. One is that, obviously reading NTSB's report conclusions, there are more than a few things that regulators should be doing, in my opinion. So if so, what are those things? And has NHTSA been responsive to these recommendations?
So we updated a number of recommendations in this latest report. We focused on specifics of driver monitoring systems. So not just a driver monitoring system that could prevent disengagement, but we were much more specific, focusing on these short glance durations to the forward roadway, saying that you need to minimize disengagement. We focused on, as we talked about earlier, obstructions to the forward roadway. If you're holding an object, it doesn't have to be a cell phone, it could be a book or a newspaper, whatever it is. If it's blocking your view of the forward roadway, that needs to be improved. We focused on the need for the Department of Transportation, DOT, to provide guidance on SAE level 2 vehicles for the manufacturers. And that includes, by design, engaging the driver. That also includes having automatic emergency braking be engaged. It has to be required to be engaged when you have a partial automation system. We think intelligent speed assist needs to be involved with this. And of course, we think, 20 miles per hour, 30 miles per hour above the speed limit, we need tighter speed controls. And that all gets back to we want to stack known, proven technologies that can help us mitigate or avoid crashes together to try and prevent or mitigate the crashes by design. Of course, we need to have the data telemetrized. If we don't know about a crash, how can we learn? How can we learn to improve if we don't know that a crash has happened? And then we need the recorded data to be on the vehicle to be able to have that learning. So there's a number of safety recommendations that we have issued in this report. Some of them we've also updated. We talked about it. Some of these things aren't new. It's not like we just learned about it through these crashes. We saw this in the first fatal partial automation crash and had recommendations from 2017 that address this. So we updated some of those recommendations. But ultimately, we see that these systems can be improved. And that's what we're focusing on. We think L2 systems need to have this type of guidance. We can't just jump to the full automation and see that as the panacea for the future. We need to solve the problems for today. And the majority of our vehicles have some sort of SAE level 2 functionality. So we think it's really critical that those systems need to be have that type of design from the get-go that focuses on safety.
Right. And have you heard from NHTSA? What are they? How are they responding to your recommendations?
And Ford as well. While we're at it, I mean, is Ford changing?
Yeah,
the
well, for car
monitoring?
companies, yeah.
So Ford, as I said, has been an active participant in our investigations, and that I believe was beneficial for NTSB, of course. I also believe it was beneficial for Ford, for them to participate as a party to our investigations, because as we were going through this process, they were seeing some of the challenges and some of the deficiencies, and I'm hopeful that they will take those to heart and look for improvements. NHTSA also, because we've talked about some of these being recommendations from 2017. So there are some areas that they have not taken action on, and I'm hopeful that based on the learnings that we have from these two crashes, that they will see an opportunity to improve so that they can get that thorough data for the standing general order and also provide this guidance for L2 manufacturers so that we can have these systems be as safe as possible based on what we know are the limitations and the improvements that are needed.
That's
right.
great. You guys are great at pointing out lessons that should be learned, but other folks have to actually do the learning. That's out of your, that's not something you can make happen.
Well, we
Right.
hope through circumstances like this, participating in podcasts where we can educate others, share what the circumstances were and what the challenges were. And I think when we're speaking to the engineering type folks, they then understand that makes sense. We should do that. That's a logical approach to safety. And that's where I'm very thankful that you invited me and NTSB today to be part of your podcast, because you have such a wide audience that I think we can share the lessons learned in various ways through our written report, but also in dialogues like this. So thank you again for inviting me.
Well, I
All
really
right.
appreciate all the time and energy you spent on this, and really thank you so much for being here.
Yeah.
My pleasure.
Thank you. I'm sorry that would have been a perfect ending, but there's one more question that I'm sorry to butt in. That would have been a really perfect ending. But the thing that really bothered me about these two crashes that I read in the report is the fact that I have been a reporter covering the automotive industry for a long time, and I have been treating every technology improvement as a standalone technology improvement, whether it's a DMS or AEB. There's a lot of different sensors involved, and I covered every single one of those improvements over the years. But I'm very ashamed of myself, but I had never really put things together in the system. It's just having one awesome AEB or one awesome DMS. It's not going wouldn't have solved it, wouldn't have prevented these crashes, right? So my last question to you, Kristin, is that the how who is looking after the improvements, system level improvements? That's number one. And how can the consumers know that level 2 automation is actually being made safer?
So you're bringing up the building blocks of safety.
Yeah.
It's not just a single building block that can create a safe transportation system. We need multiple building blocks stacked together. And that's what we were talking about earlier. We're talking about automatic emergency braking and lane departure prevention systems and electronic stability control. And then as we start to stack those together, we need a driver monitoring system that by design can recognize that the driver needs to be engaged. We also need the communication to the drivers to be that they need to be engaged, that these systems aren't self-driving vehicles, that these are just assistants and they need to be engaged in the driving task. So ultimately, who's responsible? We want the regulations to set those minimum standards, but we can't skip a certain type of system. We can't skip the partial automation system, the L2 systems. We need to have regulations that define those building blocks. So we're starting to see that. We have in 2029, the automatic emergency braking, that's a building block, but it's not till 2029. NTSB is also pushing for intelligent speed assist systems. That's another building block to this component. So we already have requirements for stability control systems. That's great. So some of the building blocks are there. We have requirements for when a crash happens. We have seat belts, we have airbags, we have all sorts of systems to protect people in the crash. We need those building blocks for the pre-crash situations as well. Manufacturers are developing those systems as well. They need the guidance to be able to develop those, to look at the full safety picture and to recognize when people may be misusing or abusing the systems and how to design them by design so that the driver is engaged when they need to be engaged. So that all gets to that building blocks, and we need to recognize that we need those minimum requirements as well as guidance. And then, of course, we need to provide good marketing, good consumer information so that the drivers understand that these are not perfect self-driving systems. They're just helping them out and they need to be engaged in the driving task. And 100% cannot be impaired, cannot be distracted, can't be fatigued. They can't use these systems as a crutch to say, oh, I'm going to have a couple drinks and then the system will drive me home. No, the systems aren't perfect. You're putting yourself at risk. You're still responsible as the driver.
But let me add a building block to that came up during the hearing, which is that I posted something about alcohol monitoring. People said, I don't want to blow in a tube. It's like, well, no, the whole point is for 20 years, they've been developing technology that does not require blowing in a tube. It's looking at it's infrared looking at your bloodstream, and it's doing air monitoring in a way that your passenger is not going to set it off. And it's pretty good technology. So that's another possibility. And I would argue, this is my argument as opposed to an NTSB finding, so we're clear. I would argue that if we're seeing a huge trend of level 2 system abuse with impairment, then that's an elevated risk compared to normal driving. So you could do something like have an alcohol system that says, well, if you want to turn on level 2, you have to agree to have the alcohol impairment monitoring. And people are worried, well, what about there's false alarm and I can't drive my car after I go to the hospital? Well, if you have that arrangement, a false alarm means you don't get to turn on the level 2. It doesn't turn off your car. So there are pragmatic ways to introduce this technology. What about the cost? Well, you're already paying $10,000 for level 2 or whatever it is. The alcohol monitor is a small fraction of that. So you're not necessarily increasing the cost of a baseline car. So in my mind, an interesting opportunity here is to introduce alcohol monitoring with level 2. So the level 2 is conditioned on good alcohol monitoring, but it doesn't turn off the normal functionality for the car, and it doesn't include induced price on the baseline model, because if you don't have level 2, you don't need it.
Well, that's a wonderful building block to add to it. And as you said, it's the in-vehicle alcohol impairment detection systems are looking at that air around the driver, or it could be like when you push the button to start the vehicle, it can read through your skin what your alcohol
like a fingerprint detector on a cell phone. I mean, the same experience, right? Yeah.
Exactly. So that's a wonderful building block to add to this. And this is another reason why I love to have these types of conversations, because there's not just one solution.
Yeah.
Bill, you brought up a really great idea. If we can't implement it across the board, are there opportunities where we have higher risk that we can implement it as a starting point? And so that's where, these types of conversations, you have a great idea, others will hear other ideas. Ultimately, how do we improve the safety of these systems? Because we have way too many people dying on our roads today. We're trying to introduce systems that will be safer. We need to make sure that they are safer and that we learn when they're not or when they have challenges and work to continuously improve that. And then, like you said, almost 13,000 people dying in alcohol-involved crashes. That's way too much. We need to find the solution to that. And, if it's a stepping stone on our building blocks to get there, that sounds like a great start.
All right. Thank you very much. On that note, Kristin, we're going to have you back. I mean, this is like a beginning of the conversation. We really enjoy talking to you. Thank you so much.
Thank you for inviting me. I really had a good
Kristin.
time talking with both of you. I hope you both have a great day.
You too.
Really enjoyed it. Thank you.
Thank you.
Take care. Bye.
Bye.